Hello everyone. In this video, we will learn about the theorem of equal ratios. Before starting the theorem, first we will see in short what is a ratio. See here there are 3 apples and 4 mangoes. Okay. Ratio is a comparison of two quantities. So we have already seen the previous video. Ratio means the comparison of two numbers. So ratio of apples to mangoes is equal to 3:4. Okay. First apples we have. So apples is how much? 3 is to the number of mangoes is 4. So the ratio of apples is to mango is 3:4. Now this is how you write ratio. Okay. Or you can also write the ratio as 3/4. Okay. The first number will be there in the numerator and the second number will be there in the denominator. So I have explained all these things previously in my channel. I will give the link of that videos in the description and the I button. You can check it out. So we will directly start with the theorem. Okay. Now we will see the theorem of equal ratios. Theorem of equal ratios. Okay. Now we will see the theorem. See, if A upon B is equal to C upon D. Okay. Here there are two ratios. Okay. See, A upon B is the first ratio and C upon D is the second ratio. Okay. So, both these ratios are equal. Okay. Then, A upon B is equal to A plus C upon B plus D equal to C upon D. Okay. This means, see, if two ratios are equal, then the sum of the numerator of the ratios upon the sum of the denominator of the ratios will be equal to the original ratio. Okay. See, we will see this with the example. I will explain this with an example. Okay. Now see here the example. A upon B is equal to 3 upon 8. Okay. And C upon D we have taken as 12 upon 32. Now we will see if this theorem is true or not. See, A upon B is 3 upon 8. Now see here, C upon D is what? 12 upon 32. Okay. Now 12 upon 32. See, you can reduce this fraction. Okay. The numerator and denominator. You can divide it by which number? 4, right? See, 4 3s are 12 and 4 8s are 32. Okay. So here what we will get? Equal to 3 upon 8. Divide both numerator and denominator by a common number. 12 divided by 4 upon 32 divided by 4. Okay. Understood how we got this? So 12 divided by 4 is 3. Okay. And 32 divided by 4 is 8. Okay. So C upon D is also 3 upon 8. And 3 upon 8 is what? A upon B. Okay. So which is equal to what? A upon B. Okay. So here both these ratios A upon B and C upon D are equal. Okay. So therefore A upon B is equal to C upon D. We will see A plus C upon B plus D. So A plus C upon B plus D. So which is equal to A plus C is A is 3 plus C is 12 upon B. B is 8 plus D is 32. Okay. So which is equal to how much? 3 plus 12 is 15 upon 8 plus 32 is 40. Okay. 15 upon 40. 15 upon 40. Now again you can divide both numerator and denominator by a common number. Which number? 5. Okay. 5 3s are 15 upon 5 8s are 40. So which is equal to what we are getting? 3 upon 8. Okay. See, again we got 3 upon 8. 3 upon 8 which is equal to what? So which is equal to A upon B which is equal to C upon D. Also we got 3 upon 8. C upon D. Okay, understood? A plus C upon B plus D is equal to A upon B equal to C upon D. Okay, this I have explained with the examples of numbers. Okay, now we will prove this theorem. Now we will see the proof of this theorem. Now we will prove this theorem. See, if this A upon B is equal to C upon D, that is given. Okay, this part is given. This part is given part. Then we have to prove this. Okay, this we have to prove. See, in the first step, what we will do? See, A upon B is equal to C upon D. That is given, right? We will assume the value as K. So what we will do? We will take the value of this number which will be equal to some K. Okay, we don't know what is that value, so we will take it equal to K. ये जो ratio का value है वो हम K assume करेंगे. Okay, we will take the value as K. Now K is any unknown number. Okay, we don't know the value. Okay, therefore what we will get? See, I will show here. A upon B is equal to K. Okay. See, if both this equal to K, then A upon B is equal to K and C upon D is also equal to K. A upon B is equal to K. Therefore, what we will get? A is equal to, this A will be equal to, this we have to cross multiply, right? BK. Okay. BK, and see, this value of C will be equal to D into K. DK. Okay. We will cross multiply. Understood how you will get this? So this we will write it here. Okay, the next step is A is equal to BK and C is equal to DK. Okay, just now I have shown how this step will come. Okay, so next step, therefore, see what we have to prove. We have to prove A upon B equal to C upon D. This both will be equal to this term. Okay, this term will be equal to A upon B. That we have to prove, right? So what we will do, we will write this step. Okay, A plus C upon B plus D. This we will write. Okay, now A plus C upon B plus D. Okay, so what we will do, the value of A, what we got, instead of A we will write this. A is equal to what? BK, and instead of C we will write this, C equal to DK. Okay, so A is what? BK, so BK plus C is what? DK, DK upon B plus D we will write as it is. Okay, so B plus D. Okay, which is equal to, see the numerator, BK plus DK. Here K we can take common. दोनों terms में K है. Okay, in both the terms K is there, so we can take it common outside the bracket. Okay, from both the terms. So what we will get? K we have taken it outside the bracket, and inside what will remain? B plus D. See here, DK is there. No, the K we have taken it common, right? So D will remain. Okay. Now the whole upon B plus D. That we will write it as it is. B plus D. Okay. Now see, which is equal to, now see here. See here also B plus D is there. Here also B plus D is there. And K is multiplied only with the numerator. Okay. So this B plus D and this B plus D. B plus D from numerator and B plus D from the denominator will get cancelled. Okay. B plus D upon B plus D will be 1. Okay. So here only 1 will remain. So K into 1 will be K. Okay. So what we will get? K. Okay. This is the answer. Now see here. Therefore, A plus C upon B plus D is equal to, what is the value we are getting? K. Okay, after cancelling the common terms from the numerator and the denominator, the answer we are getting is K. Okay, now see here, this K. What is the value of K? Now the value of K, what we have assumed? We have assumed K as this. A upon B is equal to C upon D. This value we have taken as K. Okay, see, from here and from here. So instead of K, we can write this value. Okay, therefore, see here, this A plus C upon B plus D is equal to, instead of K, what we have done? We have written this value. Okay, see here. Therefore, A plus C upon B plus D is equal to A upon B is equal to C upon D. See, this is what we have to prove, right? We have got the answer here. Okay. So this is the final answer. Therefore, a plus c upon b plus d is equal to a upon b is equal to c upon d. Okay. So this is called the theorem of equal ratios. Okay. Now we will see the general form of theorem of equal ratios. Now we will see the general form of this theorem. See, we know that a upon b is equal to al upon bl. Okay, L is any non-zero number. If there is a fraction, okay, numerator upon denominator, if that is there, then we can multiply by any non-zero number in the numerator and denominator and the ratio will be equal, right? This we know. फ्रैक्शन है, इसमें ऊपर और नीचे कोई भी नंबर सेम अगर हम मल्टीप्लाई करेंगे तो उसका वैल्यू सेम रहेगा. ओके. See, if we multiply by any non-zero number in both numerator and denominator, the same number, then the value will be same, right? A upon b is equal to al upon bl and c upon d is equal to cm upon dm. Okay. See, here we are multiplying both numerator and denominator by another number m. C. Therefore, if A upon B is equal to C upon D is equal to K, then this from here, okay, AL upon BL will be equal to CM upon DM. Because see, if A upon B is equal to C upon D, then AL upon BL is equal to CM upon DM, which will be equal to, by applying this theorem of equal ratio, what we will get? AL plus CM upon BL plus DM, which is equal to K. Okay. So this part is one of the form of theorem of equal ratios. Okay. For solving problems, we can use the theorem of equal ratios in this way also. Okay. Now we will see one more form, general form. See here. If A upon B is equal to C upon D is equal to E upon F. This theorem of equal ratios, we can use this theorem for ratio if there are three or more equal ratios. So finite terms. Okay, if finite terms of equal ratios are there, then also you can use this theorem. Okay, so if A upon B is equal to C upon D is equal to E upon F equal to and so on. Okay, like this we can have finite terms. Finite means countable number of terms. Okay, limited number of terms we can have 3, 4, 5, 6 ratios. If these ratios are equal and if L, M, N are non-zero numbers, okay, then what we will get? Then each ratio, okay, here there are more than 3 ratios are there. So each ratio will be equal to AL plus CM plus EN plus so on upon BL plus DM plus FN plus so on. Okay. Finite number of terms. Okay. So this means the theorem of equal ratios, we can use it for more than 3 equal ratios. Okay. So if 3 or more ratios are equal and if LMN are non-zero numbers, then each ratio, okay, or this each ratio, okay, A upon B, C upon D, E upon F, each ratio will be equal to AL plus CM plus EN plus so on upon BL plus DM plus FN plus so on. Okay, finite terms. So this is the general form of theorem of equal ratios. Here we end this video. I hope this video was useful to you. If you have any doubt in this topic, please write it in the comments. Please like and share this video and don't forget to subscribe to my channel. Thank you for watching.